Hello everyone. Today we are going to see about student t-test. The t-distribution was discovered by W.A. Gossett, who published this under the pen name student. A t-test is a statistical hypothesis test used to test whether the difference between the response of two groups is statistically significant or not. In case of observations that are naturally paired, the t-test is applied to the mean of the differences between these pairs. This is to visualize whether such a mean is significantly less, greater, or zero. The general procedure followed are calculation of pooled standard deviation, use of pooled SD to calculate standard error, ratio of observed difference to SC. T-table helps us in drawing inference. In t-distribution, the df, that is degree of freedom, used is equal to n-1 or 1 less than the size of the sample. When t-test involves the difference between two means, then df is n1 plus n2 minus 2. Applications of t-test. The t-test has number of applications in statistics which are discussed below. T-test for significance of single mean, population variance being unknown. T-test for the significance of the difference between two means, the population variances being equal. T-test for significance of an observed sample correlation coefficient. Statistician focuses on the distribution of differences between two groups to enable him to test a null hypothesis. NH equal to mu1 minus mu2 equal to 0 or NH mu1 minus mu2 not equal to 0. Assumption in t-test. In all statistical procedures, theoretical assumption is common, so also in t-test. We assume that underlying population data are normally distributed. The test for the above theoretical assumption is possible by graphic representation or by goodness of fit test of chi-square. When t-test is used for noting the difference between two samples, we assume that the population variances are really the same, that is homogeneity of variances. Sigma 1 square equal to sigma 2 square equal to sigma 3 square. T-test is based on the assumption that population is normally distributed. The test is somewhat easier and also distribution free is paired test. T-test for independent sample means should not be done for paired means when there is strong positive correlation between pairs with respect to measuring parameters. Formula. To test the difference between sample mean and population mean, the formula is T is equal to x bar minus mu divided by S by root of n, where S equal to sample standard deviation is calculated by root of sigma x minus x bar the whole square divided by n minus 1. X bar is the sample mean, mu is the population mean, n is the number of observation, and df is taken as n minus 1. To test for the difference between two samples, the formula is T is equal to x1 bar minus x2 bar divided by S into root of 1 by n1 plus 1 by n2. x1 bar and x2 bar are means of two samples. S is the pooled standard deviation which is found out by S equal to root of n1 s1 square plus n2 s2 square divided by n1 plus n2 minus 2, where s1 square equal to sigma x1 minus x bar the whole square divided by n1 minus 1. S2 square is equal to sigma x2 minus x bar the whole square divided by n2 minus 1. n1 and n2 are sample size and the df will be n1 plus n2 minus 2 since two samples are used. T-test for paired observations. Take the differences between the data of the pairs directly. If there is no difference, it is 0. If it is more, it is positive, and if it is less, it is negative. T is equal to d dash divided by s by root of n. D dash is the average of the differences between paired observations. S is equal to root of sigma d1 minus d dash the whole square divided by n minus 1. Steps followed are: difference under each category pair is noted while reference made above. Mean of these differences is found out, that is d dash. NH is set d dash equals 0. Sample SD is found where n is number of pairs of observation. Applying t-test formula, statistical inference with df equal to n minus 1. T-test for correlation coefficient. T is equal to r into root of n minus 2 divided by root of 1 minus r square, where r is the correlation coefficient. df equals to n minus 2. Let us see problems. A random of 10 boys had the following IQ: 70, 120, 110, etc. Do these data suggest the assumption of a population mean IQ of 100? So t-test is done to test the difference between sample mean and population mean. It is worked as under. So 3 columns are taken: x minus x bar and x minus x bar the whole square, and the given data is put in x column, and it is calculated using the formula s equal to root of sigma x minus x bar the whole square divided by n minus 1. So the values are substituted. X bar is calculated as 98.2, and the summation of x minus x bar the whole square is 1999.6. So the values are put in the given formula, and the value is calculated. So the degree of freedom is calculated as n minus 1, which is 10 minus 1, that is 9. And the t-table value with df9 p 0.05 level of significance is 2.262, and the t calculated value is less than the table value. Hence accept the null hypothesis. It is only by chance. The weight gain in pounds of experimental animal fed on diet A and diet B are given. So test whether two diets differed significantly as regards to their effect on increase in weight of experimental animals. T-test is done to test the difference between two sample means. So the x1 minus x bar and x1 minus x bar the whole square values are calculated for sample A and sample B, and the sample standard deviation variance is calculated using the formula sigma x1 minus x bar the whole square divided by n1 minus 1, and the pooled SD is calculated using the formula n1 root of n1 s1 square plus n2 s2 square by n1 plus n2 minus 2. Corresponding values are put in the formula, and the value pooled SD value is 8.78. So the formula for two sample test is t is equal to x1 bar minus x2 bar divided by s into root of 1 by n1 plus 1 by n2. So values are substituted. 28 minus 30 by 8.78 into 1 root of 1 by 12 plus 1 by 15, which gives 2 by 3.4, that is 0.5882. So degree of freedom is n1 plus n2 minus 2, that is 27 minus 2, that is 25. Table value, t-table value for df25 at p 0.05 is 2.060. So the t calculated is less than the table value for df25 p 0.05, not significant. So accept null hypothesis. Thank you.